Hello guys, so today I'm going to show you how to recover deleted files from NTFS drive, specifically made in Windows. So this is my tool which I've created, which I will showcase a tiny bit later. But first of all, I'm going to tell you about the theory of how everything works in a sense. So you have the motherboard and you have the BIOS. So you press on the power on button. It loads up the BIOS software, which is directly located on your motherboard. And the BIOS is looking for any disks that contain MBR. I specifically chose MBR. You have the disk and you have the MBR. So if a disk contains an MBR, it's in sector 0, which just means that it's in the start of the disk. So if your disk contains MBR, the BIOS recognizes it. So the MBR master boot record contains three main things. So you have the master boot routine, which contains code that gives control to the operating system. And the operating system is in one of your partitions. So you have also the partition table, which contains your partitions. And it contains, for example, which type of file system is that partition, and it also contains if it's bootable or not. So it looks for bootable devices, and you can boot up whatever OS you have there. So the master boot routine also could point to a grub or a Windows booter, which then will load whatever you choose to load, which contains the operating system. And then you have the signature, which just means that this is the end of the master boot record. So for example, after you boot up an NTFS partition, which is usually what Windows uses, I specifically here wrote dev loop because I've used the creation of NTFS in Linux first. So you have the start of the partition where you can then locate the MFT. Now the MFT is a table which contains records. Those records are, each record is a file, meaning, for example, if you go to record 1, you have attributes of the file and you have the data. So for example, an attribute could contain the dates that the file was created and the actual data. And if the file is smaller than 1024 bytes, it's called resident, which means you can contain all the data right inside as a record. But if it's more than that, it's called non-resident, meaning you need to point out to a specific location on the disk or on the partition to be exact, to then say, okay, this data is located there. And your data could also be fragmented, which means you have some data in a specific place and you have another data in another specific place, which could happen. So after tackling the basic theory, let's create a virtual hard disk in Windows. So we can do that there, right in Windows's tool. So we have the disk management of Windows. You can see here the disks that are mounted, and we are just going to create a new one. So you go to Action, you go to Create Virtual Hard Disk. We can set up the location to be, for example, the desktop, and I'm just going to save it as that name, and then the size of the disk. I'm just gonna choose gigabytes, 1, fixed size, and I'm just gonna press OK. Right after it's created, we need to initialize it. So you have two types that you can store inside the sector 0, which is the MBR and the GPT. I specifically parsed MBR. And now we need to create multiple partitions. So we do need to assign a letter for each partition. And then we are going to format it as NTFS. and allocation unit is just going to be the default, which is 512 bytes. I'm going to label the name as volume 1. And I also almost forgot that I want to give it a size of 300 bytes. And now we can finish, and we have created a partition. So I'm just going to create 2 more partitions, one for NTFS and one for something else. Great, so after creating 3 partitions, which 2 of them are going to be NTFS and one is FAT32, just to showcase my tool. Now we can go, for example, to the Explorer and see that they are indeed here. So we have the volume 2, 1, 3. Okay, so now I'm just going to create or paste some data into these partitions so we can analyze them later. All right, so right after I have added the different files that we can test, we can just go ahead to the disk management and detach the virtual hard disk. I'm just gonna make sure this is the correct one. Yes, to the desktop, correct. And this is it. So now I can just take the disk and copy it to my Linux system, which I have the tool. All right, so after transferring the disk to my projects folder, you can see it here. All right, so let's open my tool and let's choose the drive. Now, I didn't show you, but I have deleted some files, and there are 2 main ways you can delete a file from Windows. You can either shift delete, which deletes instantly, and you can just delete it, which sends the file to the recycle bin, and then you can clear the recycle bin. So those are the 2 ways, and it also saves up uniquely in the MFT. All right, so after I have opened my tool, you can see here, for example, if I press here the partition 1, you can see if it's bootable or not, the size in bytes, here's the size in megabytes, and this is the hex directly of the table from the partition table of the MBR. And we can scroll here to see another partition and the FAT partition, and great. So for example, I can come here to the first partition, and you can see the $sign and the name. A lot of them are just like system files that are created for NTFS, which have like it has a lot of different things. An example could be a journal, which is a way to track down and recover files later and states later if your PC, for example, crashes. You have a lot of different things here, but I'm just going to focus on recovering files. So you have here passwords, and then when I press here, you can see the standard information, which I am parsing from the bytes of the attributes. Same for file name and data. I've chosen just mainly 3 attributes since they give off a lot of information. And so we have passwords, which is the folder that I've created. And for example, we have bank here. So we have the record number, we have like the magic file, and we have record offset. Record offset is where it's located on the disk, and we have flags. So mainly what we are going to focus on is flag 0 and 1. So flag 1 means the file is active, flag 0 means the file is deleted or has been deleted. So we can go to bank, for example, press here, and you can see here a stream of data, and this is the resident file since it's under 1024 bytes, and we can see here the data. So you can see that I have deleted this file, a specific method that I said beforehand, which is shift delete. So I instantly deleted the file, and it looks like this. And I tracked down all of the files that are flag 0, which is flag deleted, not in use. I sent them here. And then we see here, for example, $sign in the name. So these files, I did not name them this way. So this is the second method that you can delete the file. So this is when you delete the file, send it to the recycle bin, and then delete the file, like clear the recycle bin. Meaning, when you do that, when you send them to the recycle bin, your file, you create basically two records. So you have the record of $R and the name, and you have $I and the name. So when we go, for example, to here, $I and some name, we can see here in the data that it's the path of the file and the file name. And we can go to the $R and then the name, and we can see here the actual data of the file. So it splits like this, and I can reconstruct it, which is very fun, into that file. So when I click here, this is the file name, and you can see the data, and this is the original record of, like file name of the record. But we are going to save it like this. Now, another thing is, I'm gonna come here, and you can see some wallpapers here. So since it's more than 1024 bytes, the file is being set like it's located in another location, not directly in the MFT record. So we have multiple streams also in the attributes. So for example, you have the data attribute, which contains data, as we've seen, but it can contain multiple data attributes, which is the stream of data attributes. Meaning, for example, we have here the stream of like where the actual data is located, which is one stream, and this is like fragment 1, so it's only one fragment. And you have also here metadata of the file, for example, where where did we download the file from, for example. We can have multiple of these, which is fantastic. And in the run list via LNC and len, well, we can calculate exactly where the file is located at and for how many for how many clusters. So this is basically it. Once I press on O, we have recovered the files. So when I did that, it created a folder with the same name of the disk recovered. You can see here all of the partitions in the disk, and it reconstructed the and copied the bytes and saved up as files. So for example, I go to partition 0, we can see here the bang.txt and the data. Same here. These are, again, all the files that I have deleted. And we can come here to partition 1, which is the files that are non-resident. And you can see here all of the metadata is here intact. Same for this, for the images. And this is basically it. So, hope you enjoyed. If you have any questions, you can write them below. And I do have a website, which I will link below. And I'm just going to post a blog about all of the project and how I'm parsing everything like to the byte level. So if you want to learn more, you can read there. And thanks. Bye-bye.